Hello everyone, today we are going to see arithmetic progression exercise 11A for class 10. This is from R.S. Agarwal. So question 1 here is show each progression is an AP arithmetic progression. Find the first term, common difference and the next term. We know the formula for this. So the first term for the first question is number 9. The difference is common difference is 15 minus 9 or 21 minus 15. So it's going to be the same. The 15 minus 9 equal to 6. To find the next term, we have to just add that 6 to this last term mentioned over here. That is 27. So 27 plus 6 equal to 33. Next question 2, the second part of the question 1 is 11, 6, 1, minus 4, wherein the first term is 11. And the difference is 6 minus 11. So that's going to be minus 5. So to find the next term, the last term is mentioned here is minus 4. So minus 4 minus 5. That's going to be minus 9. Then third question of first one. Minus 1, minus 5 by 6, minus 2 by 3, minus 1 by 2, wherein the first term is minus 1 and the difference is minus 5 by 6 minus of minus 1. So that becomes plus 1. So 5 minus 5, you have to take the LCM for this minus 5 by 6 plus 1. That's going to be minus 5 plus 6 by 6. So the answer is going to be 1 by 6. That's the next difference. Sorry, not the next term, difference. After finding the difference, we are going to find the next term of minus 1 by 2. So next term is going to be minus 1 by 2 plus 1 by 6. Again, we have to take a LCM. So with 2, 6 is 3 times. So minus 3 plus 1, because for 6 it's only one time. That's by 6. That's going to be minus 2 by 6, which by further simplifying we get minus 1 by 3. Next question 4 of question 1, part 4 of question 1 is square root of 2, square root of 8, square root of 18 and square root of 32. It goes on that way. So square root of 8 can be written as square root of 2 into 2 into 2. And the square root of 18 can be written as square root of 9 into 2. Then 32 can be written as square root of 32 can be written as square root of 16 into 2. And it goes on this way. And we already know square root of 2 into 2 is, you can take it out of square root, it becomes 2. So the remaining only one square root is present over there. So 2 into square root of 2. That's for square root of 8. Square root of 8 can be written as 2 into square root of 2. Similarly, 3 is a perfect square. 3 into 3 is 9. So 9, 3 square root of 2 it becomes, because square root of 2 remains over there. Then 16 is again a perfect square. 4 square is 16. So 4 into square root of 2. It goes this way. So now we got the first term, the difference, and we can find the next term easily. First term here is square root of 2. And the difference 2 square root of 2 minus square root of 2. So 2 square root of 2 minus 2 square root of 2 is square root of 2. That's the difference. Then same way for 3 is 2 square root of 2 minus 2 to the square root of 2. Then we are finding the next term. We can clearly know that 4 square root of 2 is the previous term. So next is going to be 5 square root of 2. That means it's a 5 perfect square. So 5, which you can write it inside square root as 5 into 5. That's 25 into 2. That becomes square root of 50. Next, fifth part of question 1. Square root of 20, comma square root of 45, comma square root of 80, comma square root of 125. It goes on this way. Square root of 20 can be written as 4 into 5, wherein 4 is a perfect square. 2 into 2 is 4. Next, 45 is 9 into 5. Square root of 80 can be written as 16 into 5. Square root of 125 can be written as square root of 25 into 5. So in this way, if you see 4, 9, 16, 25, all are perfect squares, which we can take out from the square root. 2 square root of 5 is the first term. 3 square root of 5 is the second term. I'll mention the example over here. Square root of 9 can be written as square root of 3 into 3. So we can remove the 3 into 3. We can write it as just 3. Remove the square root. It goes the same way for other numbers. Then 16 into 5 can be written as 4 into square root of 5. Then 5 into square root of 5. It goes on this way. So now we got all the list of terms. First term is 2 square root of 5. Next difference is equal to 3 square root of 5 minus 2 square root of 5. 3 minus 2, we know it's 1 square root of 5. Next term is going to be 6 square root of 5, which can be written as 6 into 6, that's 36. To bring it inside the square root, 6 into 6 into 5. So that's going to be square root of 180. So that's going to be the next term. Square root of 180. One more example I'm listing out. Square root of 16 can be written as 4 into 4, square root of 4 into 4. So you can write it as 4 by removing the square root. Hope this is clear. Now question 2. First part of question 2. We have to find the 20th term of arithmetic progression 9, 13, 17, 21. So we'll just know the formula of arithmetic progression, a to the n term of n. So to find an equal to a plus d minus 1, n minus 1 into d, where an is the nth term and a is the first term and d is the difference. So we are going to find 20th term. So a 20, that's equal to, we know the first term is 9 plus 20 minus 1 into the difference is 13 minus 9. So that's going to be same as 17 minus 13 also. So the difference is 4. So that's equal to 9 plus 19 into 4 equal to 9 plus 76. That's going to be 85. So the 20th term of this arithmetic progression is going to be 85. First term is 9, the difference is 4. Next part of the question is the 31st. We have to find the 35th term of arithmetic progression 20, 17, 14, 11. So we know the first term is 20 and the difference is 17 minus 20. That's going to be minus 3. So 35th term we are going to find. And the first term is 20. 20 plus 35 minus 1, and the difference we already calculated, into minus 3. 20 plus 34 into minus 3. So that's going to be 20 minus 102. So the answer is going to be minus 82. So the 35th term is going to be minus 82. Find the 18th term of arithmetic progression: square root of 2, a, square root of 18, square root of 50, square root of 98. First term is square root of 2. Difference is going to be 18 square root can be written as 9 into 2. So 9 you can take it out from the square root because it's a perfect square. So it becomes 3 square root of 2. So the 8 square root of 18 can be written as 3 square root of 2 minus first term is just square root of 2. So 3 square root of 2 minus square root of 2 is going to be 2 square root of 2. Then we are going to find the 18th term. I'm just explaining again. Square root of 18 equal to 9 into 2. So 9 is a perfect square. We can remove it from the square root. So that's going to be 3 square root of 2. Hope it's clear. So we know the arithmetic progression formula here. And we are going to find the 18th term. A18 is equal to, the first term is square root of 2. plus n in n minus 1, that's 18th term, so 18 minus 1, and the difference is 2 square root of 2. So it can be further written as square root of 2 plus 17, 18 minus 1 into 2 into square root of 2. That becomes 17 into 2, 34, square root of 2 plus 34 square root of 2. So it's just an addition. The answer is 35 square root of 2. So 18th term is going to be 35 square root of 2. Next, fourth part of the question, we need to find the 9th term of this fraction, 3 by 4, 5 by 4, 7 by 4, 9 by 4. So first term is 3 by 4. Difference is going to be 5 by 4 minus 3 by 4. Since it's a like fraction, directly you can subtract the numerators. So 2 by 4, that is simplified into 1 by 2. And the formula for arithmetic progression, we need to write it down all the time in each question. And we are going to find 9th term. So E9 equal to first term is 3 by 4 plus n is 9 minus 1. The difference is 1 by 2. So that's going to be 3 by 4 plus 9 minus 1 is 8. 8 into half. We can cut actually. 8 and 2 goes. 4 times 2 is 8. So the next 3 by 4 plus 4. So the answer is 4, 3 by 4. It's a mixed fraction. We need to write it as improper fraction. 4 into 4, 16. 16 plus 3 is 19 by 4. So first we multiply with the denominator and then add to the numerator. We get the improper fraction. Next, fifth part of the question. Find the 15th term of the arithmetic progression listed down. So the first term over here is minus 40. And the difference is, actually the second term is not 15, it's minus 15. So minus 15 minus 40, minus into minus will become plus over there. So answer is going to be 425. Minus 15 plus 40. And we are going to find the 15th term after writing the formula for arithmetic expression. A15 is equal to minus 40 plus 15 minus 1, and the difference is 25. So minus 40, 15 minus 1 becomes 14 into 25. So it's going to be written further as minus 40 plus 350. That's going to be 310. The 15th term of this arithmetic progression is 310. Question 3. Find the 37th term of the arithmetic progression. 6, 7, 3 by 4, 9, 101 by 2, 11, 1 by 4. It goes on this way. So the first term here is 6. And the difference is 7, 3 by 4 minus 6. That is 1, 3 by 4. Improper, writing it further into improper, it becomes 7 by 4. 4 plus 3 by 4. So 7 by 4. And the formula for the arithmetic progression, an equal to a plus n minus 1 into d. So this need to be written in each of the question. And we are going to find a 37th term. That's going to be 6 plus 37 minus 1 into difference is 7 by 4. So 6 plus 36 into 7 by 4. It goes 4, goes 36, goes in 4. That's 9 times. So 9 into 7 is 63. 9 times 4 is 636. So 9 into 7 is 63. 6 plus 63, that's going to be 69. Next part of the question is find the 25th term of the arithmetic progression. 5, 4, 1 by 2, 4, 3, 1 by 2, 3. It goes on. The first term is 5. Difference is 4, 1 by 2 minus 5. That's exactly 4.5 minus 5. The remaining is half. You can do LCM and check also, convert into improper and then take LCM. Either ways it's correct. It's going to be just minus half because minus 5 it's greater than 4, 1 and 1 by 2. Twenty-fifth term we are going to find. So a 25 equal to, first term is 5, 25 minus 1 and the difference is minus 1 by 2. So it becomes 5 plus 25 minus 1 is 24 into minus 1 by 2. With 2, 24 goes 12 times. So it's going to be minus 12. So 5 minus 12, that's going to be and the answer is minus 7. Next question 4. Find the value of p for which the numbers given are in arithmetic progression. So we know the difference between the second term and the first term is same as third term and second term, and it goes on this way, fourth term and third term. So that's how it goes in. If it's an arithmetic progression and it's been mentioned in question, it is a number in arithmetic progression. These are the listed numbers. So here a1 is 2p minus 1, a2 is 3p plus 1, and a3 is 11. So by substituting the formula a2 minus a1 equal to a3 minus a2, we can do this to find the value of p. So we know a2 is 3p plus 1 minus 2p, because we're going to write the value of a1, minus 2p, minus into minus plus the 1 equal to a3 value is 11. So 11 minus 3p minus 1. Plus will become minus over here. So if you see the left hand side, 3p minus 2p is p, plus 1 is given, so it's plus 2p plus 2. That's left hand side is p plus 2, and the right hand side is 11 minus 1 is 10, so 10 minus 3p. So the 3p comes to the left hand side, it becomes 4p equal to 10 minus 2, that is 8. So 4p equal to 2, the value of 4p equal to 8, so the value of p is equal to 2. Next question 5. Find the nth term of each arithmetic progression, and the first part of it is 5, 11, 17, 23. It goes on this way. We're going to find the nth term. So an equal to a plus n minus 1 into d. We know the first term is 5. Difference is 11 minus 5. That's going to be 6. So applying it on the formulae, first term is 5 plus n minus 1 into 6 is a difference, so 5 plus 6n minus 6. So 5 minus 6 we know is 1, minus 1. So it is further written as n minus 1. Second part of the question 5 is 16, 9, 2, minus 5. Same way find the nth term. So first term is 16. Difference is going to be 9 minus 16. That's going to be minus 7. So we write the formula, arithmetic progression formula, an equal to a plus n minus 1 into d. So 16 plus n minus 1 into minus 7. That becomes 16 minus 7n plus 7. So 16 plus 7, that's going to be 23. So 23 minus 7n. Hope this is useful. If you find this useful, please do share and subscribe. Thank you.